of simple APIs, practice API, REST APIs, web scraping, and working with files. Summary, but again, bugün hamdiga olmas ekanman-da. Giant application development SQL database. Okay. Create and use API in Python. Pandas is an API. REST APIs with hop, Maslow, you can create this, just like this. When you create pandas object with data frame constructor and API Lingo instance. Data. Men tushunib ketyapman. Data science men uchun emas ekan, chunki zerikarli tuyulyapti. Software engineering is good for me. application programming interface, application programming interface.
In this video, we will discuss the HTTP protocol. Specifically, we will discuss Uniform Resource Locator, or URL, request, and response. We touched on REST APIs in the last section. The HTTP protocol can be thought of as a general protocol of transferring information through the web. This includes many types of REST APIs. Recall that REST APIs function by sending a request, and the request is communicated via HTTP message. The HTTP message usually contains a JSON file. When you, the client, use a web page, your browser sends an HTTP request to the server where the page is hosted. The server tries to find the desired resource by default index.html. If your request is successful, the server will send the object to the client in an HTTP response. This includes information like the type of the resource, the length of the resource, and other information. The table under the web server represents a list of resources stored in the web server. In this case, an HTML file, PNG image, and a text file. When the request is made for the information, the web server sends the requested information, that is, one of the files. A Uniform Resource Locator, or URL, is the most popular way to find resources on the web. We can break the URL into 3 parts. First, we have the scheme. This is the protocol, and for this lab, it will always be http://. The internet address, or base URL. This will be used to find the location. Some examples include www.ibm.com and www.gitlab.com. And finally, the route. This is the location on the web server. For example, /images/idsnlogo.png. Let us review the request and response process. The following is an example of the request message for the GetRequest method. There are other HTTP methods we can use. In the start line, we have the get method. This is an HTTP method. In this case, it's requesting the file index.html. The request header passes additional information with an HTTP request. In the get method, the request header is empty. Some requests have a body. We will have an example of a request body later. The following table represents the response. The response start line contains the version number followed by a descriptive phrase. In this case, HTTP/1.0. A status code, 200, meaning success, and the descriptive phrase, OK. We have more on status codes later. The response header contains information. Finally, we have the response body containing the requested file, in this case, an HTML document. Let us look at other status codes. Some status code examples are shown in the table below. The prefix indicates the class. For example, the 100s are informational responses. 100 indicates that everything is OK so far. The 200s are successful responses. For example, 200, the request has succeeded. Anything in the 400s is bad news. 401 means the request is unauthorized. 500s stand for server errors, like 501 for not implemented. When an HTTP request is made, an HTTP method is sent. This tells the server what action to perform. A list of several HTTP methods is shown here. In the next video, we will use Python to apply the get method that retrieves data from the server. In this video, we will discuss the HTTP protocol using the requests library, a popular method for dealing with the HTTP protocol in Python. We will review Python library requests for working with the HTTP protocols, and we will provide an overview of GET requests and POST requests. Let us review the request module in Python. This is one of several libraries, including HTTP-lib and URL-lib, that can work with the HTTP protocol. Requests is a Python library that allows you to send HTTP/1.1 requests easily. We can import the library as follows. You can make a GET request via the method GET to www.ibm.com. We have the response object R. This has information about the request, like the status of the request. We can view the status code using the attribute status_code, which is 200 for OK. You can view the request headers. You can view the request body in the following line. As there is no body for a GET request, we get a none. You can view the HTTP response header using the attribute headers. This returns a Python dictionary of HTTP response headers. We can look at the dictionary values. We can obtain the date the request was sent by using the key date. The key content type indicates the type of data. Using the response object R, we can also check the encoding. As the content type is text or HTML, we can use the attribute text to display the HTML in the body. We can review the first 100 characters. You can also download other content. See the lab for more. You can use the GET method to modify the results of your query. For example, retrieving data from an API. In the lab, we will use http://bin.org, a simple HTTP request and response service. We send a GET request to the server. Like before, we have the base URL in the route. We append /get. This indicates we would like to perform a GET request. This is demonstrated in the following table. After GET is requested, we have the query string. This is part of a Uniform Resource Locator, or URL, and this sends other information to the web server. The start of the query is a question mark, followed by a series of parameter and value pairs, as shown in the table below. The first parameter name is name, and the value is Joseph. The second parameter name is ID, and the value is 123. Each pair, parameter, and value is separated by an equal sign. The series of pairs is separated by the ampersand. Let us complete an example in Python. We have the base URL with GET appended to the end. To create a query string, we use the dictionary payload. The keys are the parameter names, and the values are the value of the query string. Then we pass the dictionary payload to the params parameter of the GET function. We can print out the URL and see the name and values. We can see the request body. As the info is sent in the URL, the body has a value of none. We can print out the status code. We can view the response as text, and we can look at the key content type to look at the content type. As the content type is in the JSON, we format it using the method JSON. It returns a Python dict. The key args has the name and values for the query string. Like a GET request, a POST request is used to send data to a server, but the POST request sends the data in a request body, not the URL. In order to send the POST request in the URL, we change the route to POST. This endpoint will expect data, and it is a convenient way to configure an HTTP request to send data to a server. We have the payload dictionary. To make a POST request, we use the POST function. The variable payload is passed to the parameter data. Comparing the URL using the attribute URL from the response object of the GET and POST request, we see the POST request has no name or value pairs in its URL. We can compare the POST and GET request body. We see only the POST request has a body, and we can view the key form to get the payload. In this video, we will review hypertext markup language, or HTML, for web scraping. Lots of useful data is available on web pages, such as real estate prices and solutions to coding questions. The website Wikipedia is a repository of the world's information. If you have an understanding of HTML, you can use Python to extract this information. In this video, you will review the HTML of a basic web page, understand the composition of an HTML tag, understand HTML trees, and understand HTML tables. Let us say you had a request to find the name and salary of players in a National Basketball League from the following page. The web page is comprised of HTML. It consists of text surrounded by a series of blue text elements enclosed in angle brackets called tags. The tags tell the browser how to display the content. The data we require is in this text. The first portion contains the doc type HTML, which declares this document is an HTML document. HTML element is the root element of an HTML page, and head element contains meta information about the HTML page. Next, we have the body. This is what is displayed on the web page. This is usually the data we are interested in. We see the elements with an H3. This means type 3 heading, which makes the text larger and bold. These tags have the names of the players. Notice the data is enclosed in the elements. It starts with an H3 in brackets and ends in a /H3 in brackets. There is also a different tag, P. This means paragraph. Each P tag contains a player's salary. Let us take a closer look at the composition of an HTML tag. Here is an example of an HTML anchor tag. It will display IBM, and when you click it, will Python, and each individual tag is an attribute name and attribute tree. Let us go over a simple example. In particular, they are the children of the HTML tag. As a descendant of the HTML. In an HTML table, we have the table tag. Each table row is defined with a TR tag, and you can also use a table header tag for the first row. The table row cell contains a set of TD tags. Each defines a table cell. For the first row, first cell, we have. For the first row, for the second row, first cell, row, second cell, we have, and so on. In this video, we will cover web scraping. After watching this video, you will be able to define web scraping, understand the role of beautiful soup objects, apply the find_all method, and web scrape a website. What would you do if you wanted to analyze hundreds of points of data to find the best players of a sports team? Would you start manually copying and pasting information from different websites into a spreadsheet, spending hours trying to find the right data, and eventually giving up because the task was too overwhelming? That is where web scraping can help. Web scraping is a process that can be used to automatically extract information from a website and can easily be accomplished within a matter of minutes and not hours. To get started, we just need a little Python code and the help of two modules named requests and beautiful soup. Let us say you were asked to find the name and salary of players in a National Basketball League from the following web page. First, we import beautiful soup. We can store the web page HTML as a string in the variable HTML. To parse a document, pass it into the beautiful soup constructor. We get the beautiful soup object, soup, which represents the document as a nested data structure. Beautiful soup represents HTML as a set of tree-like objects with methods used to parse the HTML. We will review the beautiful soup object. Using the beautiful soup object, soup, we created. The tag object corresponds to an HTML tag in the original document. For example, the tag title. Consider the tag H3. If there is more than one tag with the same name, the first element with that tag is selected. In this case, with LeBron James, we see the name is enclosed in the bold attribute B. To extract it, use the tree representation. So let us use the tree representation. The variable tag-object is located here. We can access the child of the tag or navigate down the branch as follows. You can navigate up the tree by using the parent attribute. The variable tag child is located here, and we can access the parent. This is the original tag object. We can also find the sibling of tag object. We simply use the next-sibling attribute. We can find the sibling of sibling 1. We simply use the next sibling attribute. Consider the tag-child object. You can access the attribute name and value as a key value pair in a dictionary as follows. You can return the content as a navigable string. This is like a Python string that supports beautiful soup functionality. Now let us review the method findAll. This is a filter. You can use filters to filter based on a tag's name, its attributes, the text of a string, or on some combination of these. And consider the list of pizza places. Like before, create a beautiful soup object, but this time name it table. The find_all method looks through a tag's descendants and retrieves all descendants that match your filters. Apply it to the table with the tag tr. The result is a Python iterable just like a list. Each element is a tag object for tr. This corresponds to each row in the list, including the table header. Each element is a tag object. So consider the first row. For example, we can extract the first table cell. We can also iterate through each table cell. First, we iterate through the list table rows via the variable row. Each element corresponds to a row in the table. We can apply the method findAll to find all the table cells. Then we can iterate through the then create a beautiful soup object, soup, from the variable page. It will allow you to parse through the HTML page. And you can now scrape the page. Hello, welcome to Working with Different File Formats. After watching this video, you will be able to define different file formats such as CSV, XML, and JSON, write simple programs to read and output data, and list what Python libraries are needed to extract data. When collecting data, you will find there are many different file formats that need to be collected or read in order to complete a data-driven story or analysis. When gathering the data, Python can make the process simpler with its predefined libraries. But before we explore Python, let us first check out some of the various file formats. Looking at a file name, you will notice an extension at the end of the title. These extensions let you know what type of file it is and what is needed to open it. For instance, if you see a title like fileexample.csv, you will know this is a CSV file. But this is only one example of different file types. There are many more, such as JSON or XML. When coming across these different file formats and trying to access their data, we need to utilize Python libraries to make this process easier. The first Python library to become familiar with is called pandas. By importing this library in the beginning of the code, we are then able to easily read the different file types. Since we have now imported the panda library, let us use it to read the first CSV file. In this instance, we have come across the fileexample.csv file. The first step is to assign the file to a variable, then create another variable to read the file with the help of the panda library. We can then call read_CSV function to output the data to the screen. With this example, there were no headers for the data, so it added the first line as the header. Since we do not want the first line of data as the header, let us find out how to correct this issue. Now that we have learned how to read and output the data from a CSV file, let us make it look a little more organized. From the last example, we were able to print out the data, but because the file had no headers, it printed the first line of data as the header. We easily solved this by adding a data frame attribute. We use the variable df to call the file, then add the columns attribute. By adding this one line to our program, we can then neatly organize the data output into the specified headers for each column. The next file format we will explore is the JSON file format. In this type of file, the text is written in a language-independent data format and is similar to a Python dictionary. The first step in reading this type of file is to import JSON. After importing JSON, we can add a line to open the file, call the load attribute of JSON to begin, and read the file. And lastly, we can then print the file. The next file format type is XML, also known as Extensible Markup Language. While the pandas library does not have an attribute to read this type of file, let us explore how to parse this type of file. The first step to read this type of file is to import XML. By importing this library, we can then use the eTree attribute to parse the XML file. We then add the column headers and assign them to the data frame. Then create a loop to go through the document to collect the necessary data and append the data to a data frame. In this video, you learned how to recognize different file types, how to use
خلاص اگه چون که شما میگه تخصیل شون دیگه